Okay, good afternoon, students. Am I audible clearly? You can reply me in the chat window. Am I audible clearly? Okay. So let us start with the contents. So previously we started with the uh, point that is regarding statistics. So within that we have seen how we can describe a single set of data. It means even though we are having large amount of data, so whenever we wanted to describe the data, then we need to go for multiple operations or multiple ways to represent that data. So within that, we have seen how we can go for representing this data. So consider just like calculating the mean, calculating the average, median, largest value, smallest value. So there are a number of ways to describe that data. So here we have seen through various means how we can go for representation of our data. Then we studied the concept of mean and median. So I hope probably you complete your assignment yesterday given, that is how to calculate median, variance, and variance was given for the calculation to you. Okay. Mode and quantile. These two variables have given for the calculations. It is how we can write a Python program. So I hope probably you might have written this program. So quantile, it means that this shows that is represents a maximum population, that is where the data lies, and mode, it means that which is most common value. So then we read about the correlation. Correlation, it means that which measures the relationship between two variables. That is, if I'm giving some A as input, then if I'm getting the B, then how I can calculate the relation between these two. Okay. So here, that is, we have seen here example of, that is y equal to x plus c or etc. It means here how these two variables, my input x and output y, how these two are related, that can be represented by a relation. Excuse me for a minute. So here, based on my x as input, how I calculate the y? So that is shown by a concept of correlation. So now again we have seen the covariance, that is paired analog variance. So whereas variance, it means how a single variable deviates from its mean. So it means if I'm deciding the value to calculate, then how it deviates, it means how it changes its path in terms of graph representation, etc., or in terms of data values. So correlation coefficient, this is always having three values, that is lies between three values, that is 1, 0, and -1. So if consider I'm having 1 as a value, so there is a perfect linear relationship between variables, just like the linear equation we have seen yesterday as an example. Then if the variable is 0, that is coefficient is 0, it means that there is no relation between x and y at all. And if there is a -1, it means that as my x decreases, my y increases. That is a reverse relation or negative relationship between these two variables. So this we have seen. Again, later we have to read the concept of an outlier. Outlier, it means that this is an abnormal case where the data point is separated from the maximum population. Okay, so outlier is an observation that lies an abnormal distance from other values in the random sample from a population. So this we have seen. So this example we have taken, so where I am having the maximum density of my data points or data values or population at this point. Whereas I can see here very less possibilities there. And at this point, I can see a point which is far near from the existing data points. So because of this point, I need to change or take my ranges from 0 to 100. And in terms of vertical as well, that is x-axis 0 to 100, these values, data values I have taken. And in terms of x-axis also, I have taken values from 0 to 100. But whereas if I ignore this outlier, okay, if I ignore this point, then I can say that I can have a better representation of my data. That is, I can increase my scale, X scale I can increase, and I can have maximum space for representing my existing point, within which I can see the correlation much more easily as compared to the previous. In case of previous, the much more congestion is there, which does not give me any exact data. So whereas if I can see this correlation, then I can see that I can go for maximum, that is getting the maximum correlation. So it means that whenever I'm removing the outlier, I can see that the correlation is stronger or can be easily recognized. So clear up to this point, correlation. Shall we go for next point now? Okay, so let us go for next point now. So next point is Simpson's paradox. Okay, Simpson's paradox says that if consider we are performing statistics, that is as a single unit, that is for all the groups, if we consider, that is we calculating the statistics, then there is some facts and figures we find out. And if we consider the subgrouping, or we divided the population into multiple subparts, then we can see that whatever the conclusions we have made as a at a single group, that is getting disappeared or getting reversed. Okay, for example, okay, let me read the first definition. So definition says that Simpson's paradox is a statistical phenomena where an association between two variables in a population emerges. Emerges, it means that this relation is shown, association is shown, and disappears or reverses when the population is divided into subpopulations. Okay, so at large, at a single group or at a combine, I can see that there is a relation between these two variables. But whereas if I go for subgrouping or dividing into subgroups or subparts, then I can say that that relation at all doesn't exist, or the relation is reversed. Okay, for example, let us go for example. So this is an sales data. Sales data, it means that there are two flavors of the ice cream are there. That is sinful strawberry and passionate peach. So what, in order to take the survey, what company has done? It has sold its product to the 1,000 people. Okay, 1,000 sample sites we have taken, and that was sold into some remote areas. Consider at some point strawberry was sold, and at some point peach was sold. Then here the feedback was taken that out of 1,000, how many people like this strawberry flavor, and wherever peach was sold, then whoever has 1,000 customers are there, among that it is chosen, that is how many customers like this flavor. So as per this diagram, we can see that strawberry is liked by the 800 people and peach flavor is liked by the 750 people. Okay, it means that here based on this figures, we can say that 80% of the people enjoyed sinful strawberry, whereas 75% of people enjoyed passionate peach. So it means we can make the conclusion that sinful strawberry is more likely to be preferred flavor. It means at this point we make this conclusion. But now let us go for the subgrouping. Instead of it means for the subgrouping, while taking the survey, what company has done? Company has taken out of this 1,000 customers, they have taken the separate gender-wise analysis. Gender-wise analysis, how many men are there and how many women are there. For example, within 1000 in the strawberry, I'm having 900 men and 100 women. And in case of passionate peach, where I'm having 700 men and 300 women are there. Okay, so based on this, so then they have taken the separate survey that out of 900, how many men like this flavor? Out of 100 women, how many like this flavor? Similarly, the same analysis for the peach. So then let us calculate the figures now. Okay, so 760 divided by 900, it means that 84% of the men like this strawberry, 40% of the women like sinful strawberry, whereas in case of passionate peach, 85.7% of the men like the peach and 50% of the women like the peach. So here, okay, we can figure that here 84.4, 85%, 85.7. Here I can say that this figure is greater. Again, in case of women, this 40 is the figure and here I am having 50 as a figure. So can we make conclusion that strawberry is the most, it means favorable or liked flavor at this point? Can we make the conclusion? Okay, clear? So here we can say that previously, when we are talking about this case, we had not considered that third factor, what is the gender of a person. Okay, so okay, it means that here we had not considered third factor, and that is we considered only what is the flavor of the strawberry and men or women or customer simply we have taken. But when we consider the another factor, that is in case of gender, so based on the basis of the gender, we can make conclusion that here, when it comes to the men and women, we can say that most of the, it means men also like that flavor and also women also like that flavor. It means that here I can say that on this basis, the passionate peach is the most likely flavor by all the customers. Okay. So this is an Simpson's paradox. Simpson's paradox says that here, when we talk in general, at large, we perform some statistics. Then at this point, we make some conclusion. And when we divide into subgroups, that statistics is emerges or disappears. Okay, that here the conclusion that is sinful strawberry is more likely to be flavored, preferred flavor. This conclusion we cannot make in these cases because here I can see the much more percentage of the customers have liked this passionate peach, and hence the previous conclusion is got reversed or disappeared, and that concept is called as Simpson's paradox. Okay, clear with this example? Clear with this example? Okay, you can take a look at this definition. So no problem. Okay, now let us go for the next point. I hope there is no point, no problem in this point. So here we can see that the previous conclusion in the previous step, we made the conclusion that sinful strawberry, or this flavor is most likely preferred by the users. Whereas when it comes to the subgrouping based on the gender analysis or gender wise likes, then we can the conclusion that passion peach is the most likely favored or preferred flavor by the people. Next, correlation and causation. So causation, it means that the effect and cause, that is something is some effect makes the cause, that is something is caused by something. Okay, let us come to the point. Correlation. In the correlation, we have studied that if I'm having the x variable, I can predict the y. Okay, so this is a x and y. So does it mean that x is making y to happen? No. Here correlation, it means that based on some input, how my output will change. But that doesn't mean that y is caused or effect of x. Okay. So that is a difference between correlation and causation. So for example, if x and y are strongly correlated, that might mean that x causes y. Okay. Or that y causes x. That each causes the other. So it means this some third factor causes or both. So it might be mean nothing. So it means here, if I'm having x and y are related, it doesn't mean that either of the one is caused by the other. No. Here these can be caused by some other. I cannot say that also. So causation, it means that here some, because of some effect, some cause is there. Okay, so here let us differentiate between these two terms. First is a correlation. So correlation describes an association between two variables. When one variable changes, so does the other. Okay, so correlation is a statistical indicator that relationship between two variables exists. So these variables change together. That is they correlate. That is one changes another or another changes one, etc. But this covariance is not necessarily due to the direct or indirect causal links. म्हणजे असं नाही होत की x मुळेच y होतं. Okay, no, here we cannot make this conclusion. Whereas causation, it means that changes in one variable brings about changes in other. That is, there is a cause and effect relation between the variables. The two variables are correlated with each other and there is a causal link between them. So here causal, it means that effect, that is one x variable causes y to happen. Here we are talking about the origin. Why the origin of y is x? No, but in case of correlation, it means that this x and y already exist, but how the x y will change based on the x, that is given by a correlation. So here correlation and causations, these two are the different terms. So correlation doesn't imply causations, but when it comes to the causations, always imply a correlation. That is, if based on the causations, if y is happening because of x, then certainly my x will control my y. Okay, so there are it means how to identify whether this kind of relationship between exists. That is, there are two main reasons why the correlation is not causations. So these are the problems. It means whenever we wanted to make some scientific conclusions, we need to go for two problems. First one is the third variable problem, and second one is directionality problem. So let us see what is meant by third variable problem. So third variable problem, it means that co-founding variable affects both variables to make them seem causally related when they are not. Okay, so it means that here whenever I'm controlling this, whenever I'm talking about x and y, so these will change values in between, but based on this I cannot make conclusion that each one is controlling one another. But there is some another variable or another third variable which is controlling both of these. So then it means that even though these x and y are not linked with each other, still we can see there is a relation between them. For example, here example is taken, that is ice cream sales and violent crime rates. Okay, are closely related, correlated. Correlated, it means that in summer we can say that ice cream sales increases and violent crime rates are also, it means decreases. Okay, so it doesn't mean that increasing the ice cream sales is decreasing my violent crime rates. No, here the third variable, temperature is hot, that is affecting this both of the attributes or both of the problems or both variables, that is x and y, and because of which I cannot say that x and y are related. No, they may be correlated. That is, this might happen because of third variable, but it doesn't mean that this correlation is there because of some casuations. No, here this is a third variable, temperature is there, because of which these two variables are affected. Okay, the next directionality problem is when two variables correlate and might actually have a causal relationship, but it is impossible to conclude which variable causes changes in the other. Okay, x and y is there. I know that because of x, y is changing, or because of y, x is changing. But we are unable to identify because of which, whether because of x, y is changing, or because of y, the x is changing. For example, here the scientific example is taken. Vitamin D levels are correlated with the depression. Okay, so but it is not clear whether low vitamin D causes depression or because of depression the vitamin D gets reduced. So it means that these two variables, vitamin D and depression, these two are correlated, but the cause is unknown, whether because of vitamin D the depression is there, or because of depression the vitamin D will reduce. So this is a directionality problem, and hence we can say that the correlation is always not a causation. So clear with this? Have a look at this. Let us go for repetition of directionality problem. So directionality problem, it means that here, whenever I'm talking about x and y variable, I'm unable to get whether because of x, y is generated or because of y, the x is there. Okay. For example, uh, example, let me take a minute. directionality problem. So let us consider that. I will take an example. Wait a minute. Okay, here is an example. Consider that because of this online mode, work from home, the option was there for a work mode. Okay, and because of this pandemic, this mode was much more preferred, and because of which this was preferred by the multiple, it means maximum women. So here now, even though still we don't have right now pandemic, but still we are having this mode as a working mode. So this has enabled many women to work, and because of which women employment got increased. So here I cannot say that because of women employment is increased, because of which this mode is still continued, or the mode is continued because women are working. It means that these two things are interrelated to each other. I cannot say what can be the origin. Because of this mode, women are working, or women are working because of which this mode is still available. So it means that here, directionality problem, it means that whether this x variable has caused y to happen, or because of y this x is happening. Okay, so we can say that directionality, I'm unable to get the direction, whether from x to y, whether x is controlling y or y is controlling x. So that is the directionality problem. Clear with this? Okay, or should I take another example? Okay, I will take another example. Okay, so here initially whenever we start accessing any site etc, so we might go for searching the first option. If you wanted to know about any of the concept, we might use a Google search engine. So here Google search engine is most widely used search engine. Okay, because most of the people use this search engine. This is a first direction, that Google search engine used by the maximum people. So, but it might happen that other people are using, because maximum people are using the Google search engine. Okay, so it means that use of Google and customers. This is reversible. Reversible, it means that I'm unable to, it means the directionality problem says that it cannot know the origin, whether most people are using because Google is most widely used, or most widely used, it means that Google is a search engine. Why they use that doesn't know, but Google is used by the maximum people, and maximum people use Google search engine. So it means this is a reversible. Most people use Google search engine, and Google is used by the most of the people. It means here this x use of Google and used by the maximum people. These two are the two variables: x use of Google, y number of customers. So but whether y is increased because of which x got increased, or whether x is increasing because of which the customers are increasing. That is a directionality problem. Now clear with this directionality problem? Or still not clear? Okay. Anybody else is having a problem between correlation and causation? Third variable or the previous one, Simpson's paradox? Okay, clear with this? Shall we go for next point now? So next point is probability. So in the probability, we are learning dependence and independence, conditional probability, Bayes theorem, random variables, continuous distributions, and the normal distributions. So let us start one by one. So first, what is meant by a probability? So probability means that the how that is a probability, or it means how likely the event might occur. Okay. So the concept of probability means how likely an event is about to occur or chance of occurrence of an event. Okay. So this can be given by a formula, that is P of A. It means that the probability of happening of a event. Okay. Each event we can name in terms of A, B, C, or E, F, G, etc. In any of the letters, we can name this event. So if I wanted to say that this A might happen out of all the possibilities, then the probability is that number of favorable outcomes. It means which outcomes leads A to happen, and total number of the favorable outcomes. Total number of the favorable outcomes where A can occur or A may not occur. So here the most widely used example is showing the coin or tossing the coin or flipping the coin. Any term you can use, flip, toss or etc. So here probability of head is 0.5 and probability of tail is also 0.5. So here I can say that probability of head is 1 and there are two favorable outcomes, that is head and tail, and because of which the head occurrence probability is 1 by 2, that is 0.5. So probability always occurs between 0 to 1. That is a fixed rule. Okay. So again, there are some terms related to probability when it comes to data science. These terms already you might have studied in probability also, but let us revise those terms. So first one is dependence and independence. So what is meant by dependence and independence? If consider we are having two events, that is E and F. If there are two events E and F, the occurrence of F is dependent on E's occurrence. Then I can say that the two event, that is F, is dependent on E. And if consider occurrence of A is independent, whether E happens or doesn't happen, then that event is called as an independent event. So here we say that two events E and F are dependent if knowing something about whether E happens gives us information about whether F happens, or vice versa. Okay, it means that based on the occurrence of E, if we can predict for the F, then we can say that these two events are dependent, or vice versa. Vice versa, it means based on the occurrence of F, if E can be predicted or possibility, we can give some information, then we can say that these two events are dependent. And if that we cannot give some information about the next event, then we can say that these two events are independent. Okay. So for example, we wanted to flip the coin for twice. Okay. E and F are independent events. Then if consider, okay, these two are independent event, then the probability of each one happens is P of E equal to P of E multiplied by P of F. Okay, so it means these events EF will happen. Event E as well as event F will happen. The probability of E multiplied by probability of F. Okay, and here if consider the coin that is flipping the coins, this example only we will take. Okay, the consider E, that is E event is that the head will occur during the first flip. Okay, during the first flip I will have a head, and F event is tail for the second flip. I will have a tail. Then the occurrence of first will be head and tail will be second. So here, whenever I'm talking about head, the possibility of this event is 1 by 2, that will be equal to 0.5 will be there. Okay. And when I'm talking about this possibility, this is independent event. That is, the first second flip is completely independent of the first flip, and because of which the occurrence of this event is also 1 by 2, and because of which I can say that the occurrence of this event is also 0.5. But when I say that the first head and second tail will occur, that is the possibility of head and tail, this combination with between the two flips is 0.5. I got disconnected. Please don't leave the meet. Yes, I know you are entering the roll numbers, but still we are having 15 minutes. So bear with me for the next 15 minutes. Let me complete this at least dependence and independence regarding conditional probability and remaining points. We'll see later, but let me complete this. So here the occurrence of head and tail, the possibility of head is 0.5 and possibility or probability of second tail is also 0.5. Okay, it means that the complete probability of head tail, okay, we are talking about this complete event that within the two flips I will have a head, first as head and second as tail will be 0.5, sorry 25. Okay, so this will be the probability. So this will be probability for the independent events. Independent events, that is the second event is independent of the first event, and occurrence of the first event is also independent on the F, or E and F are independent. This is an example. But if consider I'm having E event as, it will show the head, that is the first probability, that is first during the first flip. This will show that head might occur. So this will be having probability as 0.5. But the F event is that two heads will be there. Okay, between the two flips, I will have two heads. This is another event. So here I can say that if I'm requesting for the two heads, based on the probability of each occurrence, I can decide or I can get some information that whether probability of occurrence of this event might be there or may not be there, or possibility is there or not. So okay, in that case, I can say that these two events are dependent event. The occurrence of the F or the occurrence of E will give information about F as an event. That is, what is the probability of F might occur. So in that case, we are having a separate formula for that. So here, yes, not separate formula, the same probability. Okay. So if consider I'm having two heads, that is, if this event is there, then I may have this probability. So again, 2 times 2 heads, I will have four possibility will be there. 2 heads, 1 head, 1 tail, 1 tail, 1 head, and 2 tails. So probability of 2 heads is 1 by 4. Okay. Then whether this occurrence of E can give me information whether this event will occur. Yes, here at this point, if the first occurrence says that this probability of occurrence of this event is 0.5, then based on this, it can also guess what can be the probability of having this as an event. Okay, so read this. If consider here at this point, the 0.5, that is 50% chances are there that head will occur. If consider at this point, if I'm saying that tell head instead of head, my this E event is regarding occurrence of the tail. Then I can say that during the first flip, if tail is there, then I can say that occurrence of F is also 0.5%. That is, the two heads probably will not occur, because if first option is tail, it means that I will never have two heads. I will have out of these two, this combination might be there. Okay. So this is regarding the dependence and independence. So clear with this? Okay. So have a look at this. Read for a minute. Okay, now. So now let us go for the next probability, that is conditional probability. Conditional probability, it means very likely to be the dependence, we can say, but not. It means not exactly. So let us see what it is. When two events E and F are independent, then by definition, we are having the probability of occurrence of these two events is probability of E multiplied by probability of F. Okay. If they are not necessarily independent, that is, if probability of F is not 0, okay, then we define the probability of E, that is conditional on F, as occurrence here. We can say that. So P of E conditional on F, okay, equal to probability of EF occurring divided by probability of occurrence of F. Okay. So here we can say that this is a, that is, if when what will happen, what is probability of E happen when the F will happen. It means what will be the probability of E happening if F is happening? That is a conditional probability. Okay, so it means occurrence of each other's event. So read this definition and give me 5 minutes for taking the attendance. Please don't leave the meet. I will take the attendance. For the time being, you can read this definition.